Can folks confirm what you're seeing on your Meetecho screen?
Looks like the agenda.
Yeah.
All right, all right. And when I stop the slide share,
now I just see a new deck is being shared.
Likewise. Now we're back to the agenda.
Now we see slides.
so let's see. So you guys are seeing the slides, and for some reason I'm not. So you're seeing the title slide right now.
Yep, we see a slide saying benchmarking methodology working group IETF111 Monday, July 26th, blah, blah, blah.
Got it. All right.
Al, are you looking at the presentation view at the top of the page or screen?
Ah, yeah, okay. All right. Now we're talking. Okay. All right. That was a good good troubleshoot, Bill. Thank you.
No problem.
All right. Well, I guess we're going to get rolling here. The appointed hour has arrived, and I think we've got most of the key players. Although I don't see my co-chair yet, Sarah, but I think we'll start with some of the preliminary stuff here and hope that Sarah's able to join us. So welcome, everybody. This is the very first session of IETF111. And it's been a long time since Benchmarking Methodology Working Group has had the privilege and the honor of kicking off IETF. But it seems that that's what we're doing today. So, so welcome. We'll be meeting for 2 hours today. The meeting will be chaired by me and Sarah. And if you're not subscribed to the BMWG mailing list, you can do that with the link in the slides. All the slides are available online in the meeting materials, and the drafts we're going to talk about today, they've all been highlighted there. So we're in pretty good shape administratively. And so now I'll move on to the next slide. Okay, slide 2. Most important is this little sentence I've added. We work as individuals and we try to be nice to each other. And that's becoming very, very important as we get deeper and deeper into the the Zoom phobia that we've all got. So let's do that. So then the rest of the note well is that it's basically a reminder of the IETF's policies on topics such as patents and code of conduct, meant to point you in the right direction. The patent policy is periodically updated. The one we're working with on this slide is as of March 2018, and so by participating in the IETF, you agree to follow the IETF processes and policies. You're aware of that any IETF contribution is covered by its patents and so forth, of which you're a sponsor. You must disclose that fact or not participate in the discussion. And as a participant or attendee, you acknowledge that any written, audio, video, or photographic records may be made public. And as a participant or an attendee, you agree to work respectfully. The personal information you provide will be handled according to the privacy statement. And really the most important thing is that anything that happens here beyond just listening, and of course our meetings are recorded, is a contribution. And therefore it's covered by this policy. And all the details for this policy are in the list of BCPs and the privacy policy link there below. Any questions at this time? Okay. So I see Sarah has joined us. Welcome, Sarah. Unfortunately, I don't see a microphone or anything for Sarah yet, so I think she may be having some difficulty with some of the other media aspects. But let's hope that she can hear us. All right, on to the next. So here's our agenda for today. What we've basically got planned is the working group status, which is 2 items. The working group drafts, which we've shuffled the order a little bit. Multiple loss ratio search is going to go quickly and first, and then on to the next generation firewall benchmarking discussion, which is going to take longer. But we hope to be able to complete that very productively today. And then we have a couple of proposals that have really had a certain amount of discussion, some more than others, but a certain amount of discussion on the mailing list recently. And it's probably it's probably time for us to start thinking about taking up some additional work here in the BMWG. And since these items have garnered some interest, it's worthwhile thinking about those. So with this agenda, are there any bashes to the agenda? Hearing none, let's run it as it's written. We've got Bill Cervani taking notes, and maybe somebody else in on Code EMD that I saw was on there. I think we've got a fairly easy way to cover Jabber now. Let's see. Trying to remember how that works. Oh, let's see. Well, let's sort of assume that whatever facility here is available for use, that folks will find it and use it, and it will be available in the meeting. Oh, look, here it is, the chat panel. Yeah, that's exactly right. So this is where we're basically taking on our Jabber inputs, and I'll be looking for the chat panel to flash red at us. And we've got 27 people online at the moment, so that's great. Good turnout for this first session. All right, so Jabber, and we've covered IPR. All right, on to the next. So here's our status, and we're basically looking at the fact that the EVPN draft is gone through its IESG review period. There's some discuss ballots to resolve, and the authors are hopefully working on that. I think there's initially I saw some progress there, but not much recently. So then the next generation firewall benchmarking document, that I may have forgotten to update some of these numbers here. I know that we had the confirmation last call, I think was on 06, and now we're all the way out to version 9, I think. Is that right?
That's correct.
Thanks.
Yep.
Okay. So there's been, I mean, since
from
the last call and actually leading up to it, actually what I see here is in my notes is that there was a working group last call on 08 in May. So that's where we stand, and we have another version, but we've still got a few comments to resolve. We're going to try to resolve them in this session. One point I wanted to point out, just an additional comment here. We've got one sentence in the draft that we agreed on. It says it obsoletes RFC 3511, but we need a sentence in the abstract all by itself that says that. And we should also add that status in the header. And if the author team needs help doing that, just let me know. I'll try to help out. All right. So as I said, the proposals keep coming, and shall we make way for new work? Well, by moving stuff in and out of the IESG and so forth. That's how we're doing that. So we're making way. We need to decide what we take up next. So here's some good news. Back in May, RFC 9004 on the back-to-back frame benchmark was published. It's an update of that particular section in RFC 2544. And so we're done with that one. And the charter's been stable thanks to the last time we updated it with Warren's joining us as AD advisor. Warren is here today. We arranged this thing so that it would be fairly stable for our work and didn't require a lot of maintenance. So I think that was the right choice, and it just lets us spend our time on doing the work instead of chartering it. And we still have a nice supplementary working group page that Sarah has provided for us. So in the milestone review, obviously there's some few things that we're still a little bit behind on, and we may have updated some of these. I forgot to check that. But we've also got a few of them that are done, and we're fairly close to picking up work that would satisfy some others. So, but as always, there's kind of a need for a milestone reconciliation, even just updating them. And that's it for the working group status. Any questions? Okay. Well then, let's see. I'm going to stop the slide share and then share preloaded slides. And now I can choose a new deck of slides. And the next one we're going to look at today is the short slide deck from MLR Search. And Masiek, if you put yourself in the queue or enable your microphone there, we'll be able to hear you in time to present this.
Okay, I think I did unmute, so can you hear me okay?
Yes, we can.
Excellent. Hi all, hi Sarah, hi everyone.
Hi.
So Vratko couldn't make it today, so I will be presenting the update on the draft. Next, so this is the multiple loss ratio search draft that we've been working within this work group for a while now. Next slide. Okay. We have posted an updated version 01 earlier in July, and I'll quickly cover the main changes, but we're looking for more reviews and comments on the list or any other way. So the main changes are really related to the points that we have I think briefly announced in the previous meeting in the IETF110. And bringing the draft in line with the open source implementation we have in LFN Fast Data I/O project. So there are some terminology updates related to the updated algorithm and the logic. The main draft update is associated with the logic improvements, specifically support for configurable number of target packet loss ratios, versus before the actual sample implementation was based on two of those. and also associated aspects related to the way that how the measurements are tracked, and versus the bounds for the rates that we are searching for. So that is that resulted in the updates in the MLR search overview section and the sample implementation section, and also reflected in the sample run that we have also updated in the example MLR search run section. So these are the main updates. Next slide. In terms of the pointers on where we are using this approach in the open source, so we're using this implementation on using T-Rex traffic generator in the LFN FDIO project, as I have mentioned. There are some pointers to the links, including description of methodology and how we're using the MLR search. Also, the Python package in a PyPy has been updated to the version 0.40, and although it is staying a bit behind of what we're running in the FDIO project, it does capture the stuff that we have updated in the draft. So the support for more than 2 target loss ratios. And that's really the update. So I'm looking for comments, reviews, and if there are any questions.
Very good. Well, thanks for that, Maciek. Any questions and or comments at this point? I think I saw Brian come through there briefly, but please queue yourself up if you want to ask some questions. All right. And I mean, it looks like there's plenty of stuff to try out here that might be beneficial to create, to prompt some comments on the draft. And so that's kind of what I recommend to folks. Is there anybody who will put their hand up and volunteer to review the draft? I mean, we picked this up with working group support, and so certainly anyone who said they would support it should be willing to review it. But it seems those people aren't here today. Oh, maybe Gabor. Yes. So, all right. And Vladimir. All right. So now I'm trying to not remove from queue. What do I want to do? So this is the thing I didn't get practice with because I didn't have a queue. Gabor, I'm going to try to remove you from the queue and see what happens. All right. All right. Okay. So, in any case, I saw 2 people join the queue, Gabor and Vladimir, and if they're willing to review the draft, that's great. So feel free to open up your mics and confirm that, if you can.
I confirm that.
Good, thanks, Vladimir.
I confirm that too.
Thank you, Gabor.
Okay, excellent. Thanks very much. Looking forward to it. Thank you, guys.
Yeah, I think, and of course I'll review this whenever and wherever I get some time. Thanks for your effort on this, Maciek, and please pass it along to Vratko too.
Will do. Thanks very much, all. Thank you. Thank you all.
Okay. So it looks like Sarah's still having some trouble joining the the call here today. Let me see if private chat will work.
Al?
Oh, yeah, Sarah, I can hear you.
Oh, good. Having browser permissions, I'm sorry. I guess Mac OS made changes in the last update or something. I apologize.
Allow cookies too.
Well, you made it just in time.
Perfect.
Wait a minute, that's not what I want. So I cancel here. All right. So it's this one, share the preloaded slides. That's not it. Here we go. Yep. Network security. Okay. All right. So we're about to pick up the benchmarking methodology for network security device discussion, and let me ask Brian, are you going to present the slides today?
Not all of the slides. I'll present the first couple of them. Then Carson and Bala will pick it up from there.
Very good. Very good. And Sarah, just to bring you up to date, Bill's helping out with notes. There were some other people in CodeMD that might be helping out as well. And so we're in pretty good shape that way.
Thank you. Do we have Jabber coverage?
Yeah, that's basically a chat in the panel here. So I mean, it's right next to the number of participants in on your Miteco screen.
Right. I just wanted to make sure did we check? I'll check to see if the Jabber button from the agenda page matches this.
Yeah. Okay. So she's okay on chat. All right. Or your traditional client works as well. Someone says cross. Oh, client. That's that's Karsten. Okay.
I see. Okay. Cool. Thank you. Thank you, Carson.
All right. So go ahead. Kick us off here, Brian. And
Sure. So,
and incidentally, what I want to do is I want to leave about 15 minutes each for the remaining two presentations, if we can. So by my calculation, that gives us an hour and 5 minutes.
okay, just so you know, I'll be taking some handwritten notes as well once I stop speaking, so I can can transcribe them and share them with you if you want.
Except that, okay, that's great. No, I'm sorry. I'm thinking I'm doing two things at once here, and the silly countdown clock appears right in the middle of the slides for me, and I couldn't move it, so that's not going to work. I'll just keep track of the time. All right, so yeah, figure on a little more than an hour, and please go ahead, Brian, whenever you're ready.
All right, just go to the next slide, please.
All right.
So the agenda is pretty straightforward. Just a quick presentation on the timeline and the draft status, and then Carson and Bala will review the open comments and then discuss next steps at the end of the discussion. Next slide. Al. All right. So just so you know, I'm going to just talk about this slide mainly. We have a second slide, or the next slide, and the one after that presents timeline in a lot more detail. But I won't go through those ones at the same time. But the initial proposal for the draft was November of 2017, where it was proposed and accepted. And we uploaded the first draft about a month after that, and then received initial comments from folks in the BMWG about a month after that. So the first 5 drafts were under Bala's name until they were formally adopted by the BMWG and in December of 2018. So it took about a year and a bit before it became a formal work item as far as the BMWG goes. We released the first draft against that in March 2019. Between March 2019 and March 2020, we had 5 draft versions. Had a lot of good discussions at IETF 104 through 109. Received comments from a number of people, as you can see itemized here. I won't bother reading it out, but it was a significant number of contributions and comments made. So we really appreciate that an awful lot. Then the working group last call was started last December. And then the second working group last call was started in May of this year. We've received in total about 150 comments and suggestions from about 12 contributors during the last calls via email, post to the benchmark working group mailing lists. And all of the comments were resolved, with the exception of comments that we received from Sarah on May 20th and July 12th. Of those comments, I think we've resolved pretty much everything with the exception of about 6 of them. So we have today's discussion will focus on that 6+ issues that need to be resolved in order to move forward. Does anybody have any questions or comments before we move on? All right, then. So if you go, thanks a lot. So as I said, around 30 comments and suggestions were posted to the mailing list by Sarah on March 20th. It says here 11. Guess my math isn't all very good, but there were some initial responses that were sort of not agreed to in toto. So this gives you a basic idea of what bucket the comments fall in: the scope definitions, the test bed environment, and the traffic mix. And it's worth noting that none of these comments that we believe actually relate to the core sections of the draft. That is the actual specifications of the benchmarking methodology. Next slide, Al. So at this point, I'm going to pass this over to Bala and Carson, who will discuss the technical details of the comments. Guys?
Thanks, Brian. So this is Carsten speaking. Let's dive right into the remaining open comments. And I'm not sure, we have just, grouped them in the way they came in. Maybe some of them are related to each other, but let's just start. So we have a couple that are related to the scope definition. And so I think we don't need to reread the text or anything. Sarah can probably comment by herself. And so from our point of view, the reason to replace RFC 3511 is really that, we're covering the old scope of firewalls, we're covering additional ones, and the question was, what is this term next-gen firewall? we researched a little bit, how it's being used. And there was also a message from Gabor. And we shamelessly took Gabor's proposal here as the author's proposal in the bottom, marked as blue, to resolve this comment. So we would suggest to define the next generation firewall as something like widely used for the modern state-of-the-art technology firewalls that can do application-level traffic inspection, including several, sometimes optional features. And yes, we could list optional features if desired. So I don't know, Al, how do you want to run this? Should we have like comment resolution on each of these, or how should we do this?
Yeah, I suggest we work them one by one, if that's okay with you, Sarah.
Yeah, so I really appreciate, Gabor, I did see your email. I just hadn't had a chance to respond yet. I did see that, and I appreciated the due diligence. And hey, if the scope is around NG firewalls and this is the definition you want to use, I think that makes a lot of sense. And I also like saying, by the way, sometimes optional features, because not everybody has everything, right? So yeah, I really like what's in blue. That makes a lot of sense to me.
Yeah, and it includes the word modern. Which Carsten and I had a little bit of a laugh about.
Yeah, I could almost hear Scott Bradner's sort of comments to us here, right? But the notion that, hey, we're trying to classify it as putting the year around that, I thought really helped. And then being specific around application level traffic inspection and then having optional features, I thought the sum of that there made a lot of sense.
Thank you. That sounds great. So I could assume that once we add this text to the draft, then we can consider this comment resolved. And Al, I'm happy with modern as long as nobody says we've created a piece of modern art.
That remains to be seen. Wow.
So we've had these question of what is a security device, and I think that was actually a very good comment, because we didn't think about the possible confusion with passive devices that would just sit there outband somewhere. And our suggestion is to update the list of the security features that any security devices in scope can have, and to describe that they must be configured in inline mode, so be active devices actually transiting or forwarding the data actively that runs through them.
Yeah, so look, from my perspective, I feel like I know it's weird. I sort of picked on the, hey, what does NG mean? Because frankly, I couldn't find a definition either. So it's really to be able to say my device is NG regardless of inline or not, I struggled with. But if we put a pin in that for just a sec, I'm not sure I 100% agree that in order to be sort of a next generation security device, you have to be active inline. I think there's the notion of next generation security devices, and some of them are inline and some of them aren't. But I think what you're trying to say is, look, if we could go with that, hey, there are next generation security devices, some that work inline, some that work out of band or passive, and this draft is going to focus on the active inline ones. I think that's a really easy way forward, because it keeps your focus clear. So you're not saying that, hey, an NG IDS, which hasn't been defined and isn't in scope of this draft, I know, but it's not that anything on the passive side couldn't be NG. It's that this draft specifically is examining the things that are configured for active inline. Would that be a fair statement of where you guys are seeing the world at too? And would that potentially work as a way forward?
I think so.
Okay.
But I mean, if anybody else has other comments, that will be the last chance now, because otherwise I think we're going to close that discussion. Any other? Okay, Alex. I don't know, Al, how you managed the queue.
Yeah, if someone wants to weigh in on a proposal that's being made other than Sarah, please do. Oh yes, and Alex has joined the queue here, so go ahead, Alex.
Okay, yeah, I wasn't sure if I should say anything before or after. Definitely I agree. Next generation doesn't really have anything to do with whether a device is inline or not. I'm from a network security vendor. We have both, firewall, next generation firewall, IPS, and any of those devices can be inline or not inline. So if a device is forwarding traffic, as Carson just said, it certainly can qualify here. But just because somebody has a IPS or next generation IPS, that doesn't necessarily mean it is a passive device. There are plenty of them that are active and can operate in both modes. So I don't know if NG implies any inline or not inline capabilities of the device.
No, it doesn't imply that. To just respond quickly, Alex. That's why we want to make it explicit. And I think we're not forbidding the use of this document for other purposes, right? But for the purpose of defining the scope, I think that's what we want to cover and what we actually do cover in the test methodology, primarily in this version. And maybe some of the after came from this big list of the grand scheme of what we might want to cover in the future.
Yeah.
But after all of this revisions, I think we're really focusing on the firewalls at this time.
Yeah, that makes, Carson, that makes a lot of sense, right? I definitely, for what it's worth, my confusion definitely came from the top, where what I interpreted and what I read was that, hey, an NG security device is this, and by the way, it has to be active in line. And I was just taking a little exception to look. I really like the idea of an NG. I really like the original premise of the draft to sort of be a little broader, but then when we sort of restricted it to only in line, that's when I was saying, well, I don't know that I agree. But it definitely was clear in your methodology that you were certainly thinking only of active in line. And so that's why I was saying, hey, if it's the notion that, look, we can talk about what all of these devices are, but then say our scope is this, and it sounds like we're agreeing, then I think that makes a lot of sense, and it removes all of the confusion for me.
Okay, cool.
One other thing I'll also say is just that the methodology only works for inline devices. This methodology cannot work for a passive device.
Correct. Well, you don't want to feedback on the network, Alex? Really?
Yeah. It requires a different kind of measurement and testing, than the one that we're putting forth.
Yep. Totally agree.
There is a comment from Warren about next-gen firewall is a stupid term. I'm not recommending or suggesting it to be changed, but it's an annoying marketing term, grub. And I completely agree, Warren, and I sympathize. We really thought about this, and I also thought, well, it sounds like marketing, but unfortunately, or fortunately, or whatever, it is the term that people use, right? And I recently sent a message on the mailing list about a Google search, and that's just overwhelmingly the term that people use. If you have any better suggestion, it's more than welcome, but we haven't found any so far.
For what it's worth, so Carson, bear with me. I totally agree. You can Google the heck out of it, but for what it's worth, when I Googled the heck out of it, I actually couldn't find anybody defining what it was. Everybody says they have one, because I think, frankly, Warren, the analysts really call it NG firewall. So you kind of get lumped that way. And I think that's why customers come at us as vendors with, are you an NG firewall or are you not, right? So I totally understand wanting to use it. And I want to be clear, I was a little not super comfortable with it, because it was originally the scope I thought was really broad for everything. And with it being specifically around NG firewalls, I think that makes a lot of sense. And I totally accept, I think, Carson's early on comment, or Brian wrote it, but somebody on the author team had said, hey, this is sort of a well-known thing. It kind of is. It's a really weird example of everybody knows what an NG firewall is, even though nobody's really defined what the heck it is. But because we're narrowing that scope, I think, for me, I'm okay with this now.
Okay, cool. I think we're in violent agreement on this one, and I'm trying to encourage us to go on to the next, given that we've got about 50 minutes left.
Because there's always the danger to get hung up on naming discussions.
Right.
Okay, so the next one is still kind of related, and we already discussed the inline part. There's also the question of fail close or fail open. So fail open means that in the worst case, if a device is overwhelmed by too much traffic incoming, for example, it was just open the floodgates and let everything through. We've actually seen that in our lab, to our utter disgrace. But that's not what we're looking for in this draft. So failure scenarios like fail open are out of scope, and we would clarify that as well.
Yeah, makes perfect sense.
Any other
Okay.
comments on this one? Okay, and please let's go to comment number 4. It's actually a different topic. Yeah, right. And now we're entering the area of these ancillary or helper devices. And I understand that raised some concerns and also confusion. Why do we need them? Why do we want them? Actually, nobody wants routers or switches in the testbed, but sometimes they're needed. And I summarized like 3 scenarios when they will be needed. The first one here on top means, for example, you have a measurement equipment which has, for example, 10 gigabit Ethernet physical interfaces, and the system under test has 40 gigabit Ethernet. And obviously, it's not possible to connect them directly. So auxiliary switches or one auxiliary switch is needed for link aggregation. Link aggregation could be understood as Ethernet or in a different way on the IP level, but we don't care for this here. But in fact, that's the first point, the first option when these auxiliary routers or switches are needed. The second option might be, sometimes we've seen measurement equipment, for example, in the virtualized space. Of course, not T-Rex, if Patrick is still listening, but some other virtualized measurement equipment that is not reaching line rate on each of its interfaces. And so in this case as well, if you want to test line rate against the SUT's interfaces, then auxiliary switch is required to fill them up. For example, in this middle scenario here that you can see in the center right part of the slide, I assume that each of these 10 gigabit Ethernet physical links can generate at most 2.5 gigabit per second frames for a specific test scenario, and then 4 of each links are required to fill one 10 gigabit Ethernet link towards the SUT. And the last example would be if we have advanced scenarios, for example, when we use specifically open source tools, which might one of them might be the traffic tool, the other one might be the attack tool, and the threat emulation tool. And in that case, we would have the traffic coming from 2 different sources. And so there's an auxiliary switch, again, needed to combine the traffic towards the system under test. So these are the 3 examples that I can think of where these routers and switches, unfortunately, are needed. And that's why we introduced them.
So Karsten, if I could say, look, I totally agree. I think, from my perspective, at least, I think, I was always taught, minimize the amount of variables that you have in your test bed, because not for these tests, for example, but I have a test going in my lab right now where my auxiliary switch is actually introducing a 500 millisecond delay. And maybe that's acceptable and maybe it isn't, but it's just another variable in the equation that you have to take into account for or not. And so maybe the advice is, look, where you can simplify, but we do understand when we're testing that for these 3 reasons, these are the 3 different use cases we see where you might have to use them. When I read that, I'll have to go back and reread it. So maybe it's there and I'm just not remembering it. When I read it, I knew that, I figured that's where you were going, but I was always mindful of, in past years where Scott would get up and he would say, hey, well, the more boxes you have in your test bed, how do you know the results you're getting on the SUT are accurate versus introduced by something else? And I think that's kind of where you're going anyways. Like, look, if you can simplify and directly connect your measurement equipment to the SUT, do it. But if you can't, and here are the reasons why we've seen sometimes that is impossible, be mindful of it and go forth. Is that an accurate sort of summary of where you sort of view the world, or do you view it differently?
I think there are a couple of techniques, and that's why Yuri is queuing up and Alex as well. Maybe we should let them come up first.
Yeah, so Alex was first. Alex, try to keep your comments brief, guys, please.
2 other scenarios that I, have. I totally agree with Sarah that you want to keep it simple, but and this is more, one's going to be on the switch side, one is going to be on the router side. Just in general, in placement of these network security devices that are in people's network, they are generally, behind a router or switch. And one of the things that we've seen that happens on testing is if you have the test equipment which is simulating lots and lots of clients, you end up getting a flood of MAC addresses, which does not generally happen in the customer environment because there are layer 3 devices between the end clients and the actual security device. The second one, and this is one more for on the router side, is when I have a virtual router, and this is usually within the test tool, it becomes extremely easy for me to do a back-to-back test, which is what I will do in order to eliminate any other devices in line. Like I want to do a back-to-back test, make sure the system under test is not in there. I can characterize what the normal behavior looks like, and then when I introduce the system under test, then all I'm seeing is the difference between those two. So that both of those things are why I personally like virtual routers and switches available in the test tool.
Thanks. Yuri, something quick?
This is Yuri. I'm with one of the test vendors. So I just wanted to add a quick note that for most of our customers, we see them use switches in between our test equipment and devices under test. And that's just from a practicality point of view, so that they can easily test lots of different equipment setups and versions. And generally speaking, today, the switch latency is a rounding error relative to the latency of a next generation firewall. So generally speaking, I don't see many people worrying about how much additional latency they add. So just wanted to add that from what we see in the field.
Thanks for your perspective.
Yeah, I picked the switch as just an example. I generally agree, and also, frankly, I also agree that we usually see customers doing things from a Tor or using a switch anyhow. But it was also about routers, and the minute you have other functions happening on other devices, you inherently open up the variables of what's impacting your test. And I like what Alex said, right? Establishing your baseline as close as you can back to back allows you to understand or rule out, frankly, that, yep, using that router didn't change a thing and I'm good to go. But either which way, I think all of the comments make sense. I just wanted to make sure that color comes through because there's a lot of testing know-how on this call right now. And I think the draft would do well to have some of those comments shared forth. That was really the only intent there.
We'll just make a recording of this meeting and normative annex of the
Cool.
But to respond, I think if you maybe look at section 5 once more, we do recommend a pre-test because yes, I do agree the latency should not be a problem anymore, but of course there could be surprises, there could be other types of surprises, and to eliminate this and to make these auxiliary switches a known component and a well-defined component of the test bed, not influencing the actual results, we recommend in section 5 to conduct a pre-test. We can rename it as a reference test or baseline test if you prefer this term.
So I think we're agreeing that we want to add some notes into the draft based on today's discussion. And the recording will be available soon.
Yeah, and
right.
The previous comment addresses here too, right? Because Carsten, if the goal is, look, try to keep it as simple as you can, but if you need to, you could add a switch here or you could add a router there. Again, I think we're leading with trying to keep things as minimal as possible, and or how do you establish your baseline, to Alex's point, and doing things back to back. So now you understand as you add these other layer 3 bumps on the wire, you understand that there is or isn't a delta. I think if that's the direction we're going, then this comment here kind of gets caught up in that, and we're good.
Yeah, and as Yuri pointed out, the next generation switches are in the rounding error for their latency. That's cool. All right, so I think we've dealt with this one.
Yep.
And then on to 5 of 11 here, Carsten.
Right. So there are two more, basically focusing on the same topic of these additional routers. And I'm not exactly sure what you would want us to change in this case, Sarah. So the question is, can we describe the one and only testbed? And I think from these 5 use case scenarios, you've seen that there are multiple different options, and that's why we described things as optional.
Yeah, you know what? This one I think is fair. I think I said I wasn't sure. I think I wasn't sure what you're meaning, but now I am. So why don't I take a look, Karsten, and go back and see if I can come back with it's fair to say, hey, I might have some proposed text. What do you guys think? Would that work for you?
Yeah, in principle, yes. I'm just interested to close the whole process soon.
Yeah, I know.
Right.
No worries.
Right. So I think that's perfectly acceptable as long as it's a prompt turnaround, Sarah. And I think, while you're thinking about it, try to take care of it soon. Thank you.
Thank you, Al.
All right. So that's a good one.
Next one is on the choice of emulated routers versus real routers. I think it doesn't really matter from the terms of from the point of understanding the reference testbed, whether they're emulated or real. And so again, a pretest can figure out what the performance impact is. I'm not sure, Bella, if I'm on the right spot here. Maybe you can help me.
I would still say, though, proactively, hey, again, if it's about limiting and keeping things as simple as we can, and or having a baseline and then adding pieces so you understand the deltas or not, then I think this comment goes away with that as well, if that helps you guys move it along.
Yuri?
Made a point on this one already, but again, we see from the test vendor perspective that virtual routers are most commonly used for two reasons. One, to avoid overrunning MAC tables and things like that in the switch infrastructure between the test equipment and the DUT, but also from a realism perspective, because normally in a typical IT environment, routers or firewalls are not exposed to tens of thousands of MAC addresses. Usually there's routers in between. So it's more realistic to use virtual routers.
Okay, thanks. So I think we can skip the next one because it's the same comment from Sarah and just some additional responses from us. We've discussed them already. So let's go to number 8. So number 8 was about IDSs, and we just discussed this among the authors and other contributors, and we said, okay, it's easiest to just remove intrusion detection systems here from the scope, because we really don't want to open the whole document again and start reviewing it for the purpose of another type of device.
Yeah.
Okay. Any comments on that?
I think we had agreed to remove IDS from the list.
Right.
Okay, good. So that's resolved, because I wasn't sure how to interpret your latest reply to that.
Maybe we crossed our wires there. I think Brian's first response was, hey, we agree we're going to remove NGIDS from the list. So the minute that table comes out, the notion, I mean, never mind, an IDS doesn't typically decrypt SSL anyways, but it would matter if you're removing that from the list. It sort of organically is gone, right? So I think you're good to go there. Yeah.
Okay.
Cool.
All right.
Okay, then we had the question, which test equipment would actually work, and why should we have this section in here? Does it actually matter or not? We have, I think we've got a lot of discussions, not only with XCI Inspirant or Keysight Inspirant, but I think it's also good for people wanting to use open source generators and emulators. From my point of view, this section seemed to be helpful, but I'm not really sure if you want it to be removed or what would be your request. So.
Yeah, I honest to goodness don't remember, so I'll have to go back and look. And then I'll take note, Carson, you're asking, hey, do I want something to change, which I'll propose, or if I wanted it removed. I vaguely remember thinking it was sort of internal details that I didn't think anybody would give up. And I know you guys responded and said actually Exia Inspirant did. But I need to honestly go back and read 4311 and I'll circle back with timely feedback. Would that work?
Sure, for me. Amritam is in the queue.
Okay.
So I represent the other test vendor in this group, and yes, we are working not only between ourselves and sharing as much technical details as it can be to help the overall purpose of this draft. We're also working with other test vendors that may not have all the technologies yet, and we really welcome any third parties. And in fact, we are right now working on creating a methodology that would be as much test tool independent as possible. We are only discussing the parameters and stuff like that, and removing any vendor specific or test vendor specific details out of it.
Okay. Perfect.
And I need to add, like with my test lab hat on, that sometimes we've had customers come to us and say, like, why are your results like this? We've measured with another test equipment from another leading vendor, and the results are totally different. And we figured out in long, reference tests and sessions in our various labs that are participating in this effort, that it's actually mostly these TCP attributes that make a big difference. So, and that's why I would welcome as a test lab to have them well defined in the document, so that we do have a reference that everybody agrees to. Of course, it's still possible to measure in a different way, but then it doesn't comply with this draft.
I missed an important thing of that you said, Karsten. It was TCP something. Specified in the test equipment.
Oh, TCP TCP stack attributes. So this section 4311 is about TCP stack attributes. So it's about the window sizes, received window sizes, delayed X, retries, different TCP flags, and so on. And yes, it looks a little bit like very detailed to a reader that might stumble upon this the first time. But we found in many test cycles that these parameters really make the difference.
Absolutely, absolutely.
They really do. I guess I was surprised. Sorry, Al. Pardon me.
Yeah, it would be great if all the vendors sort of gravitated to one set. That's because then we wouldn't have these differences to worry about, at least not so much. And that's kind of at the root of the problem.
Yeah.
Go ahead, Sarah.
No, I think what Carson was I think the goal here in this section then was about having them at least tell you what the parameters are. So then to Carson's point, we've all run into that scenario where when you run the test with vendor A versus vendor B, you get wildly different results and you're like, what is going on? Carson, honestly, that's why I was surprised, because in all of my time in working with several of the large main vendors, I couldn't get that info. So I was shocked that they would give it up. And I guess it sort of begs the question, would they give it up to the Sarah's bike shop and not just Karsten because he works at EANTC? Or and if it is, it still begs the question of, hey, well, what happens with the open source tools where they may or may not have that info, and just in general getting docs out of them is tougher. But either which way, I still stand by, hey, let me go back and read it again, get the thoughts clear, because even if the open source folks didn't have it or wouldn't give it to you, or for some reason you can have it documented, I still like the idea of being able to have it, to your point. So let me circle, sir, I stand by, hey, I'll circle back with text for proposals for 911. Issue 911 on the screen, excuse me.
Right, good, thank you, Sarah. Yuri, quick comment?
The given up comment means, but the way I read the spec is it just defines key stack parameters that you can implement in test tools. Be they from my tool or somebody else or open source. And it just defines key parameters that have a certain outcome to how TCP behaves. And then the test tool, like myself, we implement those, so you have control over that. But it's not what test tool vendors give up to be in the draft, right? It's what the draft defines as key to configure.
So you're saying as a tester, I would specify the whatever n parameters that 4311 calls out, and then I would configure test tool A and test tool B with those same parameters. Is that what you're getting at?
Yeah, exactly. Like a good example is the initial congestion window size for TCP.
Yeah.
By default, on various test tools, they can be different. They can be 2, 10, and the draft just says, hey, we recommend it to be this way, because then your results between the test tools will be closest.
Yeah. Yeah. I totally didn't read it that way. So again, I'll go back and reread. And if it's not clear, then I'll propose the sentence that says some version of what you just said. I'll steal your words totally, but I'll circle back with feedback. That's really good clarification. Thank you.
Yeah, that's exactly what I was trying to get at, and apparently not saying it clear enough. Even testing with TCP is hard to begin with, and if everybody's going to use different parameters, it's going to be a mess.
Yeah.
I can feel Scott Bradner's heat on me as I say that.
Right.
All right.
Yeah, exactly.
So,
another example.
On to the next, I think, here, Kirsten.
Another example is, we can move to the next one, but just to wrap this up, another example that we had challenge with for a long time before we started this draft was the way to close TCP sessions. Yeah. And in some cases, they were closed in a kind of, interesting way to increase the benchmarking results for public data sheets. And we discussed this, at great length, and we finally agreed that we need to have the same method of closing TCP sessions in this document for benchmarking tests, like what people use in reality, and not something faster.
Yeah, it's an interesting point, right? Because not every implementation is that way, and so if you're taking two different devices that implement it differently into the lab, what do you do?
Right, and that's why it's good to specify it, and then the open source contributors and open source programs can actually look at this and say, this is the way they want to do it, and they can implement it in the same way. So I think it's probably the easiest for open source because that's normally software based, whereas some of the implementations we've even looked at are using accelerator cards, and sometimes it was not so easy to change these parameters.
Mm-hmm.
Okay, anyway, I think that's going beyond the discussion here. So the next one is documentation of this configuration and ancillary devices on both sides. We think that, if we define that the testbed must be well known and that the auxiliary switches and routers should not have an impact or should have a known impact to be subtracted from the results, then there is no reason to add a requirement to add the configuration of these switches to the documentation.
So look, on one hand, I see what you're saying. On the other hand, I'm not entirely sure I 100% trust it. Could it be negligible? Maybe. But the notion of, or at least where I was coming from, is, hey, if I'm going to repeat a test, I want to configure in my lab exactly what Karsten configured in his. And when you have ancillary devices, how routing is configured, for example, can matter or not. How large your MAC tables are can matter or not. So if you're using a physical versus a virtual. So I thought, look, rather than get into all of that and having to have that debate, if you just ask them to document what you use so it can be repeated apples to apples across any number of test runs, then you're clean. And I was a little surprised you guys pushed back on that because I thought it was just low-hanging fruit. Like, sure, document it and move on. But that's where I was coming from with that.
I think it's not, and from my point of view, it would actually be a little bit dangerous or counterproductive to add these details. For example, let's say at ENTC, we might be using a Cisco router, for example, right? And then we would put into our results, we use a Cisco router. And then it might become like required for anybody who wants to reproduce our tests to buy a Cisco router. Although there is absolutely no reason to buy one. I mean, of course, for this purpose, and it could be any other vendor's router. Maybe I should name a few other vendors to avoid this advertisement here. But
Yeah.
I mean, actually, what's important is not what are the vendors. Important is what is the effect on the test bed.
Right, but Karsten, one way to handle that exact example that you gave is instead of saying a Cisco router, you could say we used a router that held the number of, for whatever the test is, right? So these number of routes, or it was configured for BGP and OSPF, or just so whatever. You could cover the configuration without calling out the actual vendor. Do you see what I mean?
Yes.
It's just generic. I didn't mean to say, of course. Yeah, I totally understand where you're coming from. I for sure understand why you wouldn't want to say, well, it's a Juniper or Cisco or whoever, and now you're mandating they buy it. But generically, what that device was performing, so that I could you use Cisco, I use Juniper, who cares, right? So long as they were configured with the same features and for the same functions, I think that's your point. Then fine, I can repeat the tests. And now we can focus on the SUT. Do you see what I mean?
I'm not entirely sure, because we really tried very hard to make this draft independent of any specific test equipment or auxiliary equipment. And we tried to specify the methodology detailed enough so that it's reproducible no matter what. So from my understanding, maybe the other authors can comment, but from my understanding, the draft itself should create a reproducible environment if it's properly followed. It's not necessary to document additional stuff in detail. Alex is raising his hand, I think.
Yeah, go ahead. Go ahead, Alex.
I had a question for Sarah. When you said, documenting, do you just mean, hey, these were the devices in the test bed, or do you want the full configuration for all of the ancillary devices?
For every block that you have in the test bed, although I think Karsten is saying it might already be there, for every device that's configured in your test bed, specifically outside of the SUT, so any ancillary, you have to have a reason for having it. And now it occurs to me, well, maybe he's saying, yeah, well, we already did that, right? Like we're saying, look, you need to have this many, I don't know, I don't remember what the specific examples are, but if I pick on routers, like, okay, so you're using these protocols, or you're using these number of MACs, or you're using these number of clients or whatever. And if that's actually already there, then I would retract. I have to go back and take a look, I guess, but I would say then that covers it. Because yeah, I'm less worried about having a specific device that I can load on a, vendor blah's router. It wasn't about that, but more or less the function that they were performing and how they were configured so that I can replicate the test. And if that's already called out there, then I think this is this comment goes away.
So the only thing I'm just concerned is I don't think we, while some of that is in there, I don't think we go into that level of detail. So let's just use a router as an example. We may have a router that's in there that's just doing layer 3 forwarding, has some static routes in there for whatever the client and server networks are, but we don't necessarily ask that to be documented. You also mentioned, like, well, if you're using BGP or something else, like all of those configurations, while yes, they can affect some of the performance in there, I don't think we are looking at the level of detail to try and document that. We're assuming that when we do the pre-test or the back-to-back or something else, as long as everything is working in that configuration, adding the system under test, is that's the piece that we're really looking at and to measure. So hopefully whatever the characteristics and behavior during the back-to-back test is, that's your baseline, and then anything else on top of that is really what your device under test is. So I think that's what Karsten was talking about, where we're trying not to prescribe what the other pieces of the test environment should be, but we hope that the pre-test or baseline takes that out of the equation.
Yeah, so I definitely see where you're going with it. I think the rub sort of comes in like, look, well, if I as vendor A say that my device achieves performance of X, and then a customer goes out and says, well, great, I want to reproduce that in my lab. I think one of the goals generally that we promote in BMWG is having that repeatability. And so I guess I was coming at it from the perspective of, look, having the ability for Alex or Karsten or whomever to take a test that I ran in my lab and then go run it in yours and ostensibly come out the other end with the same result, provided that that's how the device is behaving. And so that's why I was sort of erring on the, how do you document it so that's the case? I see where you're going, though. I'm not saying that, hey, this is something I'm super married to. I think repeatability is, a keystone of BMWG. But if you guys want to reject the feedback, I mean, that's your choice as well.
Sure. And I would also just like to say is that, I think we have the same goals. I'm a big fan of repeatability. I'd like to, if somebody else can run the same test and get the same results. But I know even with, let's just say in my perfect world where everything is documented and two people have the exact same set of equipment and configurations, they may not necessarily be able to repeat the same things, in both cases.
Mhm.
We want to make it as, get to that same point as much as possible. But we're also, as Carsten said, trying not to prescribe people into you have to have this set of equipment in order to run these tests, because that will lock a lot of people out, from being able to do any testing.
Yeah, no, absolutely agreed.
Good.
So, Carsten, I think let's just try. Maybe we can find a balance, or I'm not sure, what the resolution of this one is.
Yeah,
Well,
I think
my
everybody
suggested
needs to look
resolution.
at the text we've got and then decide how much more to add, if anything. I think that's where we are. What do you think, Karsten?
Well, the suggested resolution is to keep things as is, because from my point of view, the way the whole draft is written, reproducibility or repeatability is achieved by specifying the methodology well enough and by requiring a reference test to verify before any actual benchmarking measurement that the test bed is working as expected. Right.
Okay.
And I mean, there is always something below the horizon of what any benchmarking document in the IETF can define. For example, it could be fiber types to blame. Your cables could be too long, and I don't know what. But that's kind of assumed. I think that there is a minimum level of what we can describe, and above that, we just need to make sure it's reproducible. And then it doesn't matter whether it's BGP or OSPF if it's reproducible and the testbed is reference tested before. Because otherwise we wouldn't end. We would write pages and pages and pages of testbed description.
You've described the situation very well, and there's already a lot of detail here that people are going to have to appreciate. So so let's leave it at that, and if folks have serious misgivings later, then I'm sure they'll let us know. Thanks.
Okay, the last one is about the question, what is a relevant application traffic mix? And if you move forward, thank you. Then I think there was reference to the term definition missing, and we suggest to add the word relevant into the paragraph 711. So the new text is written there just to explain what do we mean when we say relevant application traffic mix.
Yeah, I was literally just asking you a question, not making a critique for what it's worth. But the proposed text here, I think, is super clear as well. So that works. That's really nice. Thank you.
So these actual application traffic mixes are a subject of discussion, and I think that goes beyond the draft. So the draft opens up the opportunity to have different traffic mixes, but relevant for different use case scenarios or industries or whatever. And actually, the NetSec Open Group is working on a couple of application traffic mixes, so we will be able to provide examples in the future, but that's explicitly beyond the scope of this document to actually define the traffic mixes.
Yeah, I was actually going to say when you guys came back to this to potentially propose some examples, but I think no matter what, examples never make everybody happy anyway, so having one as a starting point is nice. Agreed, it's not required. And to your point, documenting what the heck you did so you can repeat it is, I think, the key thing, and that's what you cover. So I think you're good here.
Great. Okay.
Cool. So that's about that. And I think, I mean, on one hand, there could be other discussions. Maybe we should ask first if there are any other comments to the draft at this point.
All right, as co-chair, I'll ask that question. Are there any other comments on this version of the draft, the next generation security devices here, 09? All right. Well, then I think we've got our answer for today, and we do have a few things to resolve offline. So let's look to the availability of the next draft to set our schedule, but we'll try to move this forward as quickly as we can.
Yeah, maybe. Yeah, okay, Brian.
Yeah, Brian, go ahead.
Wanting to ask the same question. So what are the next steps here? I mean, we've had 2 working group last calls, and so how can we proceed with this document? Because it's basically only a few formulating discussions from one contributor left here.
And I think the key thing is that in the last working group, last calls, you guys actually resolved a lot of the comments during the last call, and then Sarah's comments came, and now we're working on resolving those. And what I hear is a lot of agreement on the direction that we're going in, and the development that's been done here, and most importantly, the scope and the coverage. So I think the working group is behind us if we move this forward, and so we have a few last details to straighten out, and we'll go from there.
Okay, thanks.
Question, if I might. So Al, do you think it would be best for us to sort of like resolve all the items that aren't quite completely resolved, work directly with Sarah, then produce the draft, and go from that point? Because I think it's reasonable to say that Sarah has provided a lot of interesting feedback that I'd like to see resolved.
Oh yeah, absolutely. I mean,
okay.
Look,
so once draft version 10 has been posted, what happens then?
So let me ask the working group. We've got 25 people assembled, a couple of people on Jabber and so forth. Does anyone want to take another last look at this draft after the final changes we've discussed today? Doesn't sound like it. Now, as document shepherd, I'm going to have to take a last look at it,
right?
Because that's my job, and that gives people time to read it if they want, and to say something if they must. But I don't foresee the need for yet another working group last call here. We've had 2 really productive ones, and lots of really productive discussions. I have to add, one of my concerns early on was that when we took this work up, that all the work would be done in NetSec Open, and we'd be presented with a finished product here, and BMWG wouldn't be able, or there wouldn't be much BMWG participation. Well, that hasn't happened. In fact, what we want to happen happened, and that is that the working group participants have contributed to this extensively. So I think it's a great product of the working group's effort, with a great start all along the way with new features at various points from the NetSec Open group, and we shouldn't hold on to this any longer. We should get the next steps going.
What are the next steps? Said once version 10 has been posted and everyone's provided that last little bit of speak now or forever hold your peace. what happens then?
So as document shepherd, I have to review the draft one more time.
Right.
And I may come back with comments related to NITS checking and some other things like that, like that update, obsoletes 3511 point that I made early on in the working group status. And we probably need to fix those before we hand it to Warren for his area director review. And Warren's going to review this, and Warren's very likely going to have some comments and areas where we can improve the draft before it goes to the next step, which would be IETF last call. And then once we've resolved the last call comments, and during the last call, IETF last call, we usually get the directorate reviews from places like the general area review team, security review team, and transport area and others that try to help us out. And then it goes to the IESG, the Internet Engineering Steering Group, where more area directors like Warren will get their first chance to read it. And so expect some comments at that level. Expect some more work to do at that level. Expect some of it to come at the last minute because I've still got bricks that hit bricks on the floor here that hit my head hours before something was supposed to be approved, and then spent a good amount of time dealing with them. So it's it's an approval process with many steps, and that's why I'm trying to get us to the point where we can move this along. And I realize that I'm in the critical path for the next step. Once version 10 comes out, then I got to do my job again. So I'll do the best I can with that, and we'll try to see what happens next. Okay.
All right. So if you were a betting man, and I think you know what direction I'm headed with this, if you were a betting man, would you predict 6 months, 3 months, 1 year, 2 years? Like, what's your gut telling you?
Well, there's some fixed time intervals in the process, like the IETF last call. That usually takes 2 or 3 weeks, something like that.
Right.
And then there's some uncertainty about the amount of time to resolve the comments, and we're about to hit the August-ish vacation period where people are going to disappear for weeks at a time. But I'm really hopeful that we could get this through last call and in front of the IESG, let's say like sometime in October, and then it really pays off for the authors to be really attentive to the area director comments that come at that point and resolve them with the area directors as quickly as possible, and then you can reach an approval point once it's been on the IESG telechat agenda. You can reach an approval point very quickly after the telechat. You just start putting stuff into working text, propose resolutions. We're not going to get any showstoppers at that point. It's really about dealing with things that the area directors read that was unclear, things that they thought of that we haven't thought of, and I'll now turn it over to Warren to give his perspective.
I was just going to add, especially once it reaches AD review stage, don't be afraid to send reminders and promptings of like, yo, get a move on, get this done. So
that's something I'm very good at.
Okay, great.
The other thing I'd add, hey, if I put on my RSOC hat for a sec, is when you guys do get to auth 48, so after Warren signs off, ISG is good to go. Once you guys are in the queue, you have a long list of authors. And I think we still, the RFC editors still want to hear, or excuse me, oh gosh, not Heather. Oh, Warren, keep me honest. What do we call Sandy and Alice?
RFC editors?
Oh, thank you. So I had it right. So look, they're looking to make sure everybody agrees. So make sure that everybody is attentive, and when they're sending, hey, are you guys good? Or hey, do you agree? Or that type of language. As long as you guys are responding to that pretty quickly, it'll help auth 48 go faster. Because I think the typical stage for a draft this size, I don't think it has any contingencies here, is roughly around 12 weeks. So you want to fit into that 12-week category. And anything you guys can do, particularly in being responsive to them, will help that.
Thanks, Sarah. Appreciate it.
And I think it's once it enters the RFC editor queue, I think it's 6 weeks until they start prodding the authors. So as long as the authors notice and respond quickly, that should be able to be out in, another 2. Of course, if the authors don't respond quickly, it could be years.
It's 12. That's what I was saying. It's technically speaking, that entire process can take 12. But yeah, or I think 75% of our RFCs fall into that. But just making sure, hey, be attentive. It'll go as fast as it can. I think we're saying the same thing.
Okay. Hey, Bill's joined the queue. Bill.
Is to make your document as RFC editor ready as you can. Because the more opportunities you make for the RFC editor to make changes, the greater the possibility that what they change may not be what you intend. That's just my humble opinion.
Right. So we'll definitely be leaning on the folks that are on the call for help in that definition of what RFC editor ready actually means. So, this is our first kick at the can, I think.
So Al is really good at that. He talked about making sure your nits are clean. You have a really good document shepherd. So I'm pretty sure when you guys come out the end of that process, you'll be relatively good to go there. The English is pretty good. The grammar is pretty good already. So yeah, and if you have questions, ask us. We're happy to help.
Great, thank you.
Yeah. But I'll also tell you that one of the drafts that I just wrote that has 37 pages ended up with 37 questions from the RFC editors, and the last question had parts A through G, and it took about 6 hours to deal with. So you can never know exactly what they're going to ask, but it's all about improving the document. So take it with that spirit.
Sure. Yeah, definitely. And Al, just so you know, you're not allowed to retire until this is done.
Yeah. Oh, yeah. Yeah. Okay. We notice. All right.
Thanks a lot thanks a lot, guys.
Okay. Thank you. Thank you too for the excellent slides and leading a really productive discussion today. Okay.
Thanks to Al, and thanks to Carson and Bao for helping pull this together.
Absolutely. All right. So we're right on time. And that means that I'm going to move us over to, let's see, where is it? Yeah, Interconnect Tester Management. And it's this one. And I think we're ready to go if you are. Where'd he go?
Hi.
Oh, Vladimir. Yes.
Yeah, it's me.
Good. Yeah, please go ahead, and I'll try to keep up.
All right. Well, we have worked on the draft during the hackathon, as usual. So this is the front page, and if you can move to the next one where there is actual content.
Right.
To the next slide, yeah. So the project has been presented already. This is the state. We have a new new version of the draft. We have been working on some running code to prove the concept is viable. So there is a now complete Python script that runs RFC 2544 test using the interface that is defined in the draft. So this is our proof of concept, and we have the device, which is hardware device with the necessary server-side instrumentation code. We use FPGA to do a hard real-time traffic generation and timing, and we have some. If you're interested in the hardware, there are these two links that you can check out about how we build it. So it's, if you go to the next slide.
Yep.
This is what it looks like when it is assembled. This is what we used during the hackathon. And this time we had two setups. One is using the same tester and doesn't need GPS time synchronization. The other one is using two testers that can be at different places to benchmark interconnect link. So this is what is different in this hackathon. We use this second scenario, which is more complex and uses some of the model which deals with that. So this is the architecture of the implementation, which we have presented. We just augmented that with this sync PPS, which now we actively use to be able to synchronize the real-time clock module. Next slide, please.
Okay.
So this is what got done, actually. The most important is that we completed the RFC 2544 script and validated the binary search algorithm. So now you have a complete command line tool that connects to these devices and performs the test with a report. And the other things are improved GPS real-time clock synchronization. There we worked on the hardware implementation, doing some disciplining of the real-time clock, and we use some of the RFCs that we deal with that to find the right way to do it. Yeah, and we still have public access to these netconf devices, so different vendors can actually connect to them and validate the netconf and Young implementation. So if you go to the next slide. Yes, so I did post generated report some time ago on the mailing list, and this is how it looks like. Now this probably too little to see, but those who are interested then can open the document itself. You can see the design, even if you're not familiar with Young and don't use it actively. The command line tool has a corresponding parameter list to what actually gets into the model. And the actual source code was listed previously. So this script, RFC 2544.python, is a single script that does the entire test. So it's very simple to use as a reference design for proving the concept. And this is the report. You can see the throughput section, the latency, frame loss rate, back-to-back frames. And one thing that is interesting is like we try to make the minimum amount of time per trail which is commanded by the RFC, and the minimum amount of trails. So if you look at this report and add the skipped trails, it's exactly 41 trails that a test running on a loopback connection of 1 gigabit takes. So this is kind of a private case, of course, but it's interesting to take it into consideration when considering RFCs that optimize that process. So if we take that and we apply this MLR search algorithm, how many trails are there going to be? So that's what I'm going to use when I do the review of that draft. I'll try to apply that to our tool. So, but I think it's a good starting point for a discussion. I think, especially this slide, someone should look into it and try to provide us with the feedback. Yeah. So.
Well, maybe we can do that right now when the slide is up, Vladimir. One thing I see here that that I don't completely understand is the result under back-to-back frames. Can you tell me a little more about that?
Okay. Now there are two choices, like starting from the least possible amount of back-to-back frames or from the maximum. So we have chosen the minimum. So first trail is with 2 back-to-back frames, then you have 4, and then you end up with a full second of back-to-back frames where there is a limit. So the test doesn't look for back-to-back frames burst longer than 1 second. That's the only limitation that is kind of not into the RFC. That's something that you have to come up in your implementation. But we use 1 second, and the maximum back-to-back frames you can put in 1 second on a 1 gig Ethernet interface is that number. So it goes up to 21 trails and figures that. So it stops there. If there was something that drops frames at an earlier point, then it would go into binary search and find the exact number. Does it sound okay?
All right. So this is configuration still at this point. Okay. All right.
But it is the running test that is printing it. So we have taken 1 second. That's the only thing that is like predefined without being part of the RFC.
Okay.
Yeah. So yeah.
Right. Okay.
Now you can probably notice that there is something that is not part of the RFC. There is a minimum and maximum latency being detected. And this is like a small deviation. The RFC requires only 1 frame to be taken at a particular location. And that should be done 20 times, as we do in that section.
That's the old latency test in RFC 2544 that basically nobody does anymore. I mean, everybody does something more more complex than that, because this was what they could do in the 90s. and it's better if I mean a lot of the current generators claim to measure delay on every frame. Some of the software generators measure delay on a sample of frames, but in any case, they all try to characterize the min and the max and the average of a more complete distribution of the frames. So they're looking at a lot more frames than just 1 in the middle of the test. Let's just leave it at that.
Yeah. That's actually easier to implement with that more complex detection than the one that is prescribed, because there you have to detect exactly a frame at a certain point. But it's interesting to mention, because we took that as like it was. I thought we should be able to do exactly what the classical RFC recommends. So it was just a lack of functionality in the model that was causing that. and we needed to have like timestamped frames to be able to do that, unless we had something that allows us to capture particular frames. And we added that to the model. Actually, this is the part we added to the configuration in the new model in the latest release. So if you go to the next slide, there is no more questions for this one. This is what we changed from 0.5 to 0.6. It's a configuration container that allows you to specify when the capture starts, and it specifies also if the buffer for capturing frames and the timestamps overflows, if you should stop or if you should overwrite that. So this is a functionality every tester has, and we added that to the model. So now we actually are able to implement the RFC like it was implemented, but it was defined with a single frame specified at a certain offset. We can capture that and we can compare the timestamps. So we haven't done the implementation yet, but something to do on the next hackathon.
Okay.
Yeah. So next slide, please. Yeah, and there are a lot of things that can be added to this model, but our goal was to add the minimum amount of functionality that can be implemented by every known tester. So now the question is, should we start working on a more complex filter configuration model? Because at the moment we have left this on the site, and we probably should do that. One thing is to consider if we should add IETF access control list, which is the IETF specification for filtering. And the other option is to use bit fields. So that's just mentioning the options. Probably we will add a young construct called choice. So you can actually implement the model with both of them or either of them. So, and that's what we wanted to present at this point.
Cool. All right. Well, any feedback for Vladimir? All right. Well, just as a working group chair here, Vladimir, I wanted to recognize that your progress with this has been continuous and prolific, and you've caught the interest of several people, providing comments on the list and so forth. I think that we might want to take this up as a working group draft, but is there any feedback on that? Particularly, I'm looking to my co-chair here, but anyone else who wants to comment at this point, do you think we're at the stage where we could adopt this draft as a working group item?
Yeah, I definitely agree with that, and I also appreciate the continued progress and very quick progress actually on the draft. So thank you for that, Vladimir.
Well, thanks. That's appreciated.
All right. Well, then that'll be an action item that we take going out of this meeting, is to start a working group adoption call on the list, and hopefully we'll it's going to be something that happens in August, but hopefully we'll get plenty of interest and enough people kind of signing up to review the draft and consider some of the other things that you're thinking about here. And I think quick feedback is let's keep it minimal, and then we can always do a secondary version of it, Vlad, later to add some more material if you think that's think that's a good idea. Okay.
Yeah, that's perfect. My approach is to only model things that I can actually implement in this improvised hardware that we have. And that kind of limits me to the basic things, even if I don't want to. So that's how it is.
Very good. Well, it's a very synergistic relationship then. Awesome. All right.
Yeah.
Well, thanks again for your presentation and all your good work today. And next up is Gabor. And Gabor, you've got 15 minutes and about 15 slides, if I remember correctly. 14, it looks like. So let's keep that in mind.
Yes, I hope that you can hear me.
Yes.
Can you hear me well?
Yes.
Thank you. So thank you much for the opportunity to present our draft about benchmarking methodology for stateful NATXY gateways using RFC 4814 pseudorandom port numbers. Could you go to the next slide? Thank you. So the first question is, why do we need a new measurement method? As you know, we have RFC 2544 and RFC 5180 as a general benchmarking methodology for network interconnect devices and for IP version 6 specific things. And we also have RFC 8219, which address the IP version 6 transition technologies where stateful NAT64 belongs to. So why do we need another methodology? It is because none of them discussed how to apply the RFC 4814 pseudorandom port numbers to any stateful NAT gateways. Stateful NAT can be the very old traditional NAT 44 or NAT 64 or even something else. So I would like to, could you go to the next slide, please? Thank you. So first, I would like to discuss why it is a hard problem to use pseudorandom port numbers with stateful NAT gateways. And then I recommend some solutions, including the test setup and terminology and the two-phase measurement method and its limitations. Could you go to the next slide, please? Thank you. So why is it a problem to use pseudorandom port numbers? Let's imagine that we have a very old traditional NAT44, let's say a home gateway or a carrier grade NAT device, doesn't matter. So it has one private side and one public side. And in the private to public direction, it is no problem that we can use any source and destination port numbers. However, if we consider the size of these ranges, and we multiply the two sizes, we got 3 billion, more than 3 billion. And it means that if we have so many source port destination port number combinations, then and we use them as just random numbers, we will exhaust the connection tracking table. So it will be denial of service attack against the device. So we may not do that. And of course, in the other direction, it's trivial, it's a problem, because if you just invent any random port numbers, the stateful NAT device will drop the packets because they do not belong to any existing connection. But we will overcome this issue too. So could you go to the next slide, please? Yes, here's a test setup. So this methodology works with any IP versions, but just for simplicity, we use the traditional NAT44. So on the left side, you can see some private IP version for addresses, and on the right side, you can see some public IP version for addresses. And you can see two devices, the tester and the device under test. And the tester has two ports, and the two ports have different roles. One of them be named initiator, and the other be named responder. We will detail what they mean. And the responder has this state table, and the device under test has the connection tracking table. Could you go to the next slide, please? So we will define different terminology, different words. So the connection tracking table resides in the stateful NAT device, and it uses this connection tracking table to be able to perform the stateful translation in the public to private direction. And of course, as we do black box testing, its size, policy, and content is not known for the tester. And under 4-tuple, we mean the 4 numbers that identify a connection. They are source IP address and destination IP address, and source port number and destination port number. And of course, it would be a 5-tuple, including the protocol TCP or UDP, but we always use UDP, and at the end we discuss the difference from TCP. And of course, as I mentioned before, the tester has 2 sides, and on the respondent side, there's a state table, and that when the tester receives frames, it extracts the 4-tuple for each received frame, and it stores the 4 tuples in its state table. Could you go to the next slide, please? Yes. So, as I mentioned, the tester has 2, let's say, ports or sides. One of them is called initiator, the other one is called responder. And the initiator is the port of the tester that may initiate a connection through the stateful device under test in the private to public direction. And the responder is the other part, is the other port or end where you can connect the device under test. And it may not initiate a connection through the stateful device under test in the public to private direction, but it may send frames that belong to an existing connection. And to achieve this, it uses the 4 tuples from the previously extracted frames and use IP addresses and port numbers from there. Of course, it selects randomly from its state table. Could you go to the next slide? Yes, thank you. So we defined a new test phase. Of course, the real test phase is the one which we use for the actual test. It can be throughput or latency or any other test. And before the real test phase, we use a so-called preliminary test phase. We introduce this test phase to support the stateful test. So in this preliminary phase, the test frames are sent only by the initiator to the responder through the device under test to fill both the connection tracking table of the device under test and the state table of the responder. So this is a new thing which we have introduced. Could you go to the next slide? Thank you. So to overcome the problem of the denial of service attack, we believe that the initiator should use restricted ranges for source and destination port numbers, but not in a symmetric way. The size of the source port number range should be somewhat larger, and the size of the destination port number range should be smaller. I can explain the reasons, but there are details. I don't go into details. And the product of the 2 sizes, 2 ranges, the size of the 2 ranges is a parameter, and the performance of the stateful NATXY gateway may be examined as a function of this parameter. Could you go to the next slide? Yes. So this is the preliminary test phase. So it serves 2 purposes. It fills the connection tracking table of the device under test. And it is important because we expect that its maximum connection establishment rate may be lower than its maximum frame forwarding that is throughput. So we have to fill it before we can test the throughput. And of course, we also have to fill it to have valid connections, and we have to fill the state table of the responder with valid 4 tuples so that the responder may be able to transmit frames that belong to existing connections. And from the very beginning of the throughput test, it has to be able to send frames. So these it means that the primary test phase is always necessary before the real test phase. However, it can be used without the real test phase to measure the maximum connection establishment rate. The next slide will be about that. No. Yeah. Yes. So it's a separate measurement which is worth doing and publishing its result, because it's an interesting characteristic feature of a stateful gateway. The maximum connection establishment rate is interesting by itself, and this determination is necessary for the safe execution of the preliminary test phase when we use it before the real test phase, because we have to fill in the tables, and we have to know at what rate we can do that. And its measurement procedure is similar to that of the throughput measurement procedure. We define it in detail in section 4.4. Could you go to the next slide? Yes, and the real test phase is when we do the actual test, but it must be preceded by the preliminary test phase, during which the frame rate is not higher than the maximum connection establishment rate, and then all the tables are filled, and then may come the real test, and we have given some details about it in section 4.5. Could you go to the next slide? Yes, of course, we have given all the details of the measurement methods in the draft, and of course, we also gave the limitations. The most important limitations, I think, is that we recommend the usage of UDP. We do it because all RFCs which we built upon use UDP for its simplicity. However, we have to be aware that stateful NATXY solutions handle UDP and TCP differently. For example, I have checked that IP tables, the net filter framework of Linux, uses 30 seconds of timeout for UDP and 60 seconds timeout for TCP. So it also means that if we do some benchmarking measurements using UDP, it may happen that our results do not perfectly characterize or not well enough characterize the behavior of NATXY gateways when they are used for forwarding internet traffic, because on the internet traffic, many times you can see UDP, for example, for carrying HTTP or something like that. And of course, if it's necessary, we can adjust, for example, timeout values, but we have to be careful with that. And of course, if we would like to examine high-level protocols, we recommend the benchmarking working group working item about network of the next-generation firewalls, which we have discussed today. So it was what I wanted to say. Just, I think we have a more slide. Yes. So all the text is written in the draft, and we have one partial implementation. In fact, the implementation supports all what I was talking about. The documentation is in this paper. It is only partial because it's was written a few months ago, and after that I implemented some other parts. I committed last week the part which solves the problem of unique pseudo-random port number combinations, which is necessary, but it was not included in that paper yet. So this is what I wanted to say, and thank you very much for listening. And I would like to ask you to comment and say your opinion if you find it useful, meaningful, or whatever you recommend to change or add. So thank you very much.
Well, thank you, Gabor. That was a very, very complete presentation. We have a few minutes here. Does anyone have any comments or feedback they'd like to give Gabor? Well, then I know there was some feedback on the list about this topic, right, Gabor?
Yes, there were some answers, and thank you very much for those who answered, and I would like to get more, of course.
Right. Right. So I think it's probably going to be more productive for us to talk about this a little bit more on the list and try to get some reviews on maybe this version or the next version of the draft, and then we'll take it from there. Okay.
Yes, so there were some comments and we answered. And on the basis of the comments, I would like to submit a new version, maybe by the end of August.
Very good. Very good. Yeah, I noticed that was one of the things that I didn't see included in your slides today. In other words, some synopsis of the discussion that you had on the list. But perhaps you could just do that in a quick email to the list, and then we'll have that information in our records. And then we'll see what the interest level is in the next version of this.
Okay, thank you.
Very good. All right. Well, we're down to our last 20 seconds. So I want to thank everybody for attending and participating today. It was a good meeting and lots of good preparation and good development results in that. The thing that will make it better is when we've got more people reading the drafts that are new and so forth. Anything more to add, Sarah?
Al, you covered it succinctly as usual. Thank you. Thanks for the good meeting, folks.
Very good. And thanks for attending, everybody. That's what makes it worthwhile. Bill, thanks so much for taking notes today. Much appreciated.